I'm Anil Kumar sharing with you solution of question number 25, page 21, Nelson. We are working on slope of tangents. Now this particular question has two parts. We'll discuss part A in this video, and in the link provided you'll find solution for part B. Consider the graph of parabola y equals to 4x squared plus 5x minus 2, at which point on the parabola is the tangent line parallel to 10x minus 2y minus 18 equals to 0. So this question is slightly different from the questions which you've done so far. Here we have to find the point on the graph where the slope is given to us. And what is that slope? The slope is given by the statement here, which is at which point on the parabola is the tangent line parallel to 10x minus 2y minus 18. So the slope should be, you can rearrange this equation and find the slope. So let's rearrange. So this equation could be written as, let me do it here. So it is 10x minus 2y minus 18 equals to 0. So we'll bring 2y to the other side, because 2y equals to 10x minus 18. Dividing by 2 we get y equals to 5x minus 9. So we are looking for slope of 5. So now the question is, consider the graph of parabola y equals to 4x squared plus 5x minus 2, at which point on this parabola is the tangent line parallel to this, means it has the slope of 5. So we are looking for slope m equals to 5 at a point on this parabola, right? So that is the whole question. So to find that point, we'll work with the general equation. We say let in general slope at any point a, we'll say x equals to a, will be equals to limit h approaches 0 of f of a plus h minus f of a over h. So that becomes the general equation. And now we will substitute a plus h for x for the first term. So what we get here is limit h approaches 0, and fa plus h means replace x with a plus h. So we get 4 times a plus h whole square plus 5 times a plus h minus 2. So that is the first term, right? So let me write down the first term in kind of brackets here, correct? So let's do this, and then we'll do take away the second term, which is f of a, right? So let's do the second term. F of a really means substitute x as a. So we get 4a squared plus 5a minus 2, right? So that becomes the second term, which is f of a, and everything here is divided by h. So that is the equation to be solved. Now you can expand and simplify. So let me just bring it towards the left a bit. H approaches 0, and expand this. So what we have here is 4 times a square plus 2ah plus h square plus, let's open this bracket, 5a plus 5h, and then we have minus 2, and then minus 4a square plus 5a minus 2, and everything divided by h. So simplify it further, limit h approaches 0. So now when you open the bracket, what do you see? You get 4a square minus 4a square. So that cancels out, right? So let me cancel this. So 4a square will cancel, 5a will also cancel, and minus 2 will also cancel. So that will give us a few lesser terms here. 4 times 2 times ah gives us 8 ah plus 4h square plus 5ah, correct? Yeah, that's it, divided by h. So that is what you get. Now here h is common, so I could write this as limit h approaches 0, and what we get here is h is common, so we get 8a plus 4h plus 5, okay, divided by h, and now we can cancel h, simplify it further. So once you do that, then what do you get? You can now substitute h equals to 0, and what you get here is 8a plus 5. Do you see that? So slope at any point x equals to a is 8a plus 5. That is your general equation for this parabola. Now what do you need? You need a point where the slope is 5. So we can equate this equation to 5 and say 5 equals to 8a plus 5. And so 8a plus 5, and we can now simplify it. So 5 take away 5 is equals to 8a, or 0 divided by 8, which is 0. So a is 0 for us. So at a equals to 0, the parabola will have a tangent whose slope will be 5. That is what the question is. So our answer here is that at x equals to 0, tangent to the parabola will be parallel to given line, that is slope m equals to 5. You get the idea. So that is how this type of question can be solved. You can follow the link to see the second part solution, where we will find slope of the tangent to be perpendicular to a given line. Okay, thank you.